Hello, my name is Khalid. I am from AI Services Lab line. I'm data scientist and software engineer sometime. So today's talk is about managing machine learning pipelines using Airflow. So anyone have used Airflow here? Okay. So I'll try to adjust depending on people's opinion. So here is agenda, basically 4 topics. So first of all, introduction about Airflow. So Airflow is workflow management system where you can schedule your jobs and it can work for ETL, for machine learning, or any job batches you have. So here is an example on the left side of code. Basically, you can write workflow using Python. So first you make DAG. DAG means directed acyclic graph. So you make the DAG, and then you can add tasks to your DAG. So in our case, we have 3 tasks. So pre-processing and training, and then inference. And finally, you can set the dependencies between your tasks. So in the result, after interpreting this code, you will get something like this on the right side. About architecture of Airflow, I'm not going to go details of architecture. It's basically master-slave architecture. So you have master node and slaves. You can scale your app by adding more slave nodes. And there is a queue to distribute the jobs, and there is metastore for consistency. And then we deploy using Ansible. Basically, it's important to have all your nodes in sync. The code on all the nodes should be in sync. And for HA, we have the standby node. So if the active node is down, we switch to the standby node. Now I'll move on more to the ML part, how we use Airflow. So this is an example of our DAG. Basically, the whole machine learning, so we're working on recommendation system. So whole recommendation system you can see in one view. So you can see all the logs from pre-processing to training, inference, validation, up till HBase. So this is a system view. So we use Spark for pre-processing. Then we do training. It's local machine training. Then we do inference in Kubernetes. And after everything is going through Kafka to HBase. So this is a general view. One thing I want to talk about is the first stage, the first operator. So in Airflow, every task is called operator. It can be SSH operator, Python operator, or Bash operator. So the first one here is something called branch operator. So in branch operator, you can separate your workflow. For example, first, the top one is for production, and the lower one for beta stage. So depending on environment, you can select multiple passes of your code. So in production, we run the green. Green means successful. So in production, we run this one, and on the beta, we have running that first pass. So basically, you can use branch operator for different passes. Next thing is usage of dates. So usage of dates is very important in Airflow because we want to keep our tasks stateless, first of all, and secondly, consistent. So you want to have the same date in all the tasks. So Airflow provides something called Jinja templates. So you can, maybe you have heard about Flask and Jinja templates. So you can use exactly the same Jinja templates in Airflow. Here is an example of that. The double curly braces means the start of syntax for the Jinja template. So you can basically use DS means date stamp. So basically, before executing the Airflow, this task, so this is Bash operator task. It means it's where is train SH. Train SH is just you're starting your training, right? And you pass argument. argument is date. You can have multiple arguments, but one of the arguments is normally date. And it will be rendered something on the right side. So depending what format you want, you can select different formats, DS or DS no dash, or you can actually access the Python datetime object. The third example is accessing the datetime object. So before rendering, you will execute Python code actually. Okay, so little bit more details. This is a little bit tricky part. So for people who are not aware of Airflow, it's a little bit complicated to explain. The key part here is two key parts. First, the start date doesn't necessarily mean when it will be run. So it will be run actually after start date plus schedule time. So the first task, if we start date put today, it will actually run tomorrow. And the execution date will be today. So this is a little bit tricky part for the advanced users of Airflow. So after you start using, I would suggest to go in details of this slide. Okay. Another thing very useful in Airflow is notifications, how you can set up notifications, especially in machine learning pipeline. Because we want to know how is the training going, we want to keep track of the loss, of training loss, validation loss, or what is our accuracy of algorithm, etc. So keeping track of the whole pipeline is important. For that, we have something called callbacks in Airflow. You can have success callback or failure callback for the DAG, or you can have same callback for the task level. So this is more fine-grained, this is DAG level. And then you can receive this kind of alerts. For example, training successfully finished, and training took 4 hours, for example, 22 minutes. And the learning rate was this one, for example. So this is very important, especially in the machine learning pipeline. Next, how we implemented the monitoring of training and inference part. So for that, let's take a look about training. So in training, one of the key metrics is loss, the validation or training loss. So sometimes, depending on the data, the training, the value of the loss can be overflown or underflown. It can be none or inf or some other values. So in that case, we cannot use the training. The training is invalid. The model itself is invalid. So we need to restart training by adjusting hyperparameters. One of the hyperparameters we adjust is normal learning rate. We decrease learning rate and restart the training again. So in this case, if the loss is invalid, we basically restart training. So keep training until the loss is valid. So this is one of the key important parts, which you can track all in the Airflow. So Airflow will keep the logs and also will send the notifications. So this is our implementation. You can send notification to Slack channel, to Line messaging group, or etc. Anywhere. Another thing is monitoring the inference. So once inference is done, we need to check if the classification scores are valid. If it's between 0 or 1, for example, what is minimum, maximum, average? Or we need to keep track of duplicates or coverage. So what is the coverage? Is the coverage changed or no? So this is done on this stage. After inference, we do validation here and check for the format. So this is, for example, score, minimum score, maximum score, and average score. Okay, and one last thing I want to talk about is using something called communication between tasks, XCOM feature. So if you want to pass some argument, in our case, signature of the model, you can push it to the task instance and you can pull it from task instance. It's not, you shouldn't use it always, but sometimes it's useful. Okay, so I think this is it. Yeah, thank you very much for attention. Yeah, thanks.